In AutoCAD, it's essential that you draw your objects at an exact size, shape, angle, etc. And to do that, you really need to have to understand the coordinate system. And there's two main types of coordinate systems that are used in AutoCAD. That's Cartesian and polar coordinates. Cartesian are the ones you're probably most familiar with. That's X, Y, and Z, that kind of thing. Polar coordinates, on the other hand, involve radius and angles. Right? We're going to use these to define our various AutoCAD objects, lines, circles, arcs. So you need these coordinate points to make sure they're exactly the right length and the right size. So here we go, our Cartesian one, that's our default one. It's going to be X and Y in 2D. And then we're going to use our polar one. That's going to be R and theta, so the radius and the angle. Now the Cartesian coordinate system we're going to limit ourselves to is just the 2D one, but realize the Cartesian coordinates come in both 2 and 3D. So for example, in the 3D one shown here, you have an X and a Y position, and then you'd have a height of Z. Now we're limiting ourselves to 2D, so we're just going to have X and Y. In our case, Z is always going to be equal to 0. In all systems, you're going to have an origin. Origin is essentially the 0 point. So for a three-dimensional one, it would be X equals 0, Y equals 0, and Z equals 0. For a two-dimensional system, it's just going to be X is equal to 0, Y is equal to 0. And you can see this is where our various axes originate from. They originate from this origin. So this would be where the point was X, Y, and Z were all equal to 0. Now, if we want to create a line using a Cartesian coordinate system, in case the line shown here, first thing you have to do is tell AutoCAD what you want to create. You can type in L or type in line, or for that matter, use the line command button, a whole bunch of different options there. Once you put that in, AutoCAD's going to ask you what is the first point of the line. So in our case, we're going to use our Cartesian coordinate systems, and we're going to put in that X is equal to 2 and Y is equal to 1. Just put that in by 2, 1, and that's going to be your start point. And obviously, it's going to be over 2 from the origin, right? That's the X value, and up 1 from the origin. That's the Y value. The next thing they're going to want to know is what is the next point, right? So AutoCAD will ask you this, specify next point, or undo. If you did something wrong, you could hit undo at this point just by hitting U, and you put in 6, 3, and this is going to draw our line from 2, 1 to 6, 3. Now, the default setting in AutoCAD is that you continue to draw lines. So then it's going to ask you what the next point is, and that would be if a line was taking off from that 6, 3 location. If you're only drawing a single line, just hit Enter, and that will draw that line and dump you out of the line command. Do not hit escape. If you hit escape, you're going to actually get dumped out of the command, and any line you created is going to disappear, right? Because you're escaping from the line command. Now let's take a look at polar coordinates. Polar coordinates essentially use an R and theta system, right? Again, we're going to limit ourselves to just a 2D polar coordinate system. So it's going to be essentially in the flat XY axis. Right? And so here we see if we want to have a point, we can define it by its distance from the origin, that's R, and the angle at which we measure that from. So in a polar coordinate system, the coordinates are R, theta. Keep in mind with the polar coordinate system, the origin is still the same, right? It's at the point where everything is essentially equal to 0. And in terms of the polar coordinate system, as long as R is equal to 0, really angle is a little bit meaningless at that point, but the origin is going to be located at 0, 0 by definition. So if you want to locate a point using the polar coordinate system, you need these two coordinates, need that radius and that angle or angular coordinate theta, right? So that will tell us where this point is located using those two values. Right? Radial coordinate is going to be in whatever length unit you're using. Angular coordinate will be in degrees. By default, the angular coordinate is 0 at the positive horizontal, or what you think of as the x-axis, the positive x-axis, and it's measured positively counterclockwise. So 45 degrees counterclockwise, 90, 135, 180, 225, etc. Now keep in mind, you can also use negative values. So instead of putting in, for example, an angle of say 315 degrees, you can also use minus 45. Instead of 270, you can use minus 90. That works just fine. Anytime you put a minus sign in, now it's going to measure it in the clockwise direction. So let's say we want to create a line. We put our first put in our L or line command, right? A bunch of different ways you can do that. And then you put in your value, and in this case it's a radius of 2.5 at an angle of 60. Notice now we're using this less than symbol. That's to tell you that you're using the polar coordinate system. So it's 2.5 units at an angle of 60 degrees. And if you see down here, there's the 2.5 units, there's the angle of 60 degrees, right? Just like last time, this goes through and then asks us for the second point, right? So you're drawing a line, you have to have a start point and an end point. So to specify the next point, in this case, we're going to have one that's 7 units at an angle of 10 degrees. And again, we know it's this angle because we're using this less than symbol, right? So here it is, it's 7 units long and it's at an angle of 10 degrees. So that's the start point, that's the end point. AutoCAD by default is going to think you want to continue to draw lines, so it's going to ask you for the next point in the series of lines. If you don't want to draw additional lines, just hit enter and it'll dump you out. And again, don't hit escape. That will eliminate your line. So what we've been talking about so far are all what is known as absolute coordinates. That means all of the distances are measured from the origin, that 0, 0 point. But what we find when we're drawing things is more often than not, we know how big the object we want it to be, but where exactly it's starting from can be unknown, right? You can be selecting, say, the corner of a building or the corner of a part. You know you want to draw it, say, 3 feet from there, or with a small part, maybe 2 inches from there, but you don't know the exact coordinate would be from the 0, 0 point. In that case, we want to use what are known as relative coordinates. Essentially, relative coordinates measure from whatever point you pick. So for example, if you want a 2-inch long line, you can use a relative coordinate with a 2-inch distance, and that will give you that 2-inch long line. Now, how you get that in AutoCAD is to use a symbol, the @ symbol, right? And that's placed before the coordinates, and that will tell you that you want to use relative coordinates. So instead of measuring it from the origin, it's going to measure it from whatever was the last point that was selected. So let's show you an example of that. So again, creating a line, we use L, line command, line button, etc. Pick any point you want, right? In this case, we're going to pick an unknown point. All right, and now we've got that point selected. You can just click on it with your mouse. And then when it says specify next point or undo, we put an @ 4, 2. And when we put that in, that means it's going to go over 4 units, so 4 units in the X direction and 2 units in the Y direction. By the way, we're always putting in positive numbers, but keep in mind you can put in negative numbers if, for example, you want to go down or to the left. Right? And now that's going to draw a line that is 4 units horizontally and 2 units vertically. And again, single line segment, hit enter afterwards. Keep in mind, you can combine these two, and this is kind of done very often, where again, we'll start to draw our line. We pick a point. Now we're using absolute coordinates, so 2, 1. So it's 2 units over from the origin, 1 unit or up from the origin. That's our start point. And then we switch to relative coordinates. And this time we're going to actually use relative polar coordinates. We put in @ means it's relative coordinates, 5 less than 25 or 5 angle 25. That means it's going to have a radius of 5 at an angle of 25 degrees. So again, it starts at 2, 1. Now this line is 5 units long and at an angle of 25 degrees. Right, so you can mix these together. You don't always have to stick with the same system. You can start out with absolute coordinates and switch to relative. You can start out with polar coordinates, switch to Cartesian. AutoCAD takes those commands interchangeably throughout the process. And then again, if you want only one line segment, you hit enter at the end. So there are multiple coordinate systems in AutoCAD. There's the standard one that is kind of set up and it is global. This is known as the world coordinate system. This is going to be a fixed system. You can't change that. When you start up your screen, that's where your axes are. They're sitting on your world coordinate origin. But keep in mind, oftentimes you might want to change your coordinate system. And this is what's known as a UCS, or user coordinate system. And that can be actually moved around, meaning translated. It also could be rotated. And for example, if you were, say, drawing a house, right? The house might be sitting in the world coordinate system, but then you switched over to, say, working in the kitchen of that house. You might want the bottom corner of the kitchen to be at 0, 0, at least for that time being. Or let's say you're building something that is going to be rotated at, say, 20 degrees. You might want to have the coordinate system rotated at 20 degrees. That way you don't have to keep rotating the lines and working with that. So there are times when you want to use the user coordinate system to speed things up and make things a little bit more efficient. In terms of these coordinates, keep in mind they're oftentimes going to be displayed down on the status bar. Right? And it's going to show you, in this case, the X, the Y, and the Z. For us, the Z is going to be 0, as long as we stay in the drafting settings. Right? And you can modify this in terms of using the chords control. If you type in AutoCAD CORDS, you can control whether it shows it as X, Y, and Z, or R, theta, Z, and how it's displayed. So play around with that a little bit. If you do not see this on your status line, that's because the default setting now in AutoCAD is not to have coordinates available. But go in your status line, go to that section that says Customize, click on that, and one of the options will be to turn on this chords control. So if you don't see the chords, that doesn't mean they're not there. You just have to customize it so they're displayed. Now, eventually, we're going to end up printing. For this course, we're primarily going to be printing as a PDF, but the whole setting in terms of setting this up works the same whether you're printing it to paper or you're printing it to a PDF. And one of the first things you got to decide is, what exactly am I going to print? And it's essentially, what part of your screen are you going to do? So you can do it as the display. Display is going to print everything that's in the drawing area. Right? That's fine, but oftentimes it may not be lined up very well. And especially if there's a lot of empty space around your drawing, all that empty space is going to show up in the drawing. And that's not really what we want. We want our drawing to be pretty well centered, and we want it to take up around 2/3 of the drawing area. So display oftentimes doesn't work so well. Another option is to do extents. Extents essentially prints out only what's drawn, right? So it's going to fill the page completely. So that's okay. It's not always the best we want, but that's a good command to keep in mind for later on, because once we put a border and title block on it, then we really actually do want to use extents, because we want it to, that border and title block, to fill the whole screen. Another option is to use the limits. If you've set up a limit in your drawing area and you use limit when you're printing, it'll just print that limit. But probably the most useful one of the bunch, at least initially, is going to use window. And what window allows us to do is to drag a window around a screen, and that will put that'll put that area is what's going to be printed. So just what you have in the window. And that allows you to zoom in, zoom out, or locate your drawing so it's nicely centered. So that's the one I recommend. Keep in mind, whenever you print, though, you also get to preview it. So if the window didn't work out perfectly, you can go and fix it again as well. So let's see how this works in practice. So if you're looking at your drawing area and you see something like this, right? This is your drawing, this is your origin, this is some other object that's drawn. So this is your whole drawing area. And you've gone to the trouble of defining this box as your limits on your drawing. So this is what you see. If you print with the display button, it is going to look like this. It's going to show you your entire display, right? So all this white area around the outside will be displayed. On the other hand, if you hit extents, extents is only going to be around the objects. So in this case, your drawing is an object. This diamond pattern up here is an object. So the extents is going to go right around this, and that's what's going to, your paper or your PDF is going to look like if you use extents. On the other hand, if you use limits, it's just going to do these limits, right? So just this object here, which is within the limits. Now, oftentimes you're going to be printing a drawing multiple times, so you may want to set up your preferences ahead of time, and you can do that in page setup, and you can work in the model window. In that case, you can set up anything that you specifically want. So for example, if you want to set up as limits, you want to set up with a window, you want to set up with some other particular setting, maybe a zoom setting, you can do that all in the page setup. And then that's saved so that anytime you go to print out something from that drawing, all those settings are already available for you. But it's not necessary to do that, particularly if you're only going to be printing something out once or twice. Now the page setup and the print setup is essentially the same. It looks like this. This is the dialog box that pops up. If you have a defined page setup, it'll be right here because you would have a setup that you saved. But if you just hit print, it'll pop in here. There won't be any page setup. And then you got to answer the various questions. So you got to say, what's the printer I'm going to use? Right? And then we give you the details once those are. You might want to modify the properties, right? Then what size paper do you plan on using? Letter, which is A size, B size, C size, etc. What is the plot area, right? Remember they talked about that, limits, display, window, right? If we want to scale, right? Eventually we're going to want a very specific scale, but for now we're oftentimes just going to be able to use fit for paper, right? Now keep in mind you can have other settings like offsetting it. You may want to center the plot. This is actually a nice way of getting it to look nice on your screen. There's all different types of pen styles you can do. We don't even get into that. That's from the old pen plotters that I don't think anyone even uses anymore. Now there's other options here that we'll eventually get into, things like line weights, etc. But one you're definitely going to want to use is the orientation, and that's if it's in portrait or landscape mode, right? Portrait is when it's standing up, right? And landscape is when it's essentially laying down or more horizontal. So in this case, your drawing would be wider than it is taller. If your drawing is taller than it is wider, you might want to use portrait mode, right? And once you're happy with it, you can hit OK. But if you're not 100% sure, you can always hit preview as well. And preview will show you what your drawing is going to look like. Right? So we'll continue to play around with these settings as we go along, particularly when we start talking about scale. Eventually, the print that you make should be to a very specific scale, right? And essentially, a scale is a ratio between the printed size, the output size, compared to the actual size of the object. A lot of our stuff will be small enough so we can print it full scale, mean 1:1. So when you print it out, whatever is an inch on the object is also going to be an inch on the paper. Now, on the other hand, if you have something that's a little bit larger, you might want to go to half scale. That way, everything that's an inch on the object is actually going to be a half an inch on the paper that's printed out or in the PDF. Larger objects might be quarter scale or 1/10 scale, etc. There's a whole series of different scales, and essentially it's always going to be the ratio of the object size, I mean the printed size compared to the object. So for example, in a quarter scale, everything that was something that was 4 inches long would actually only be printed out as 1 inch. Very important that when you draw in AutoCAD, you draw things in full scale, right? So even though you plan on eventually, say, printing it out half size, quarter size, etc., when you draw the object, you draw it its full size, full length, etc. So if something's an inch long, you draw it an inch long. If something is 50 feet long, you draw it 50 feet long. You worry about scale when you're outputting it, whether you're printing it or whether you're, sending it to, say, a PDF. But when you're drawing, you always draw full scale, 1:1. Right? That's very important. That's how all our dimensionings work, because we just pull our dimensions directly off the object, so they have to be the right size. Another thing to keep in mind is, although your drawing is very accurate, it still is not something you'd use to actually measure something. So for example, if you're given a drawing and you want to create the object from that drawing, you might be tempted to break out a ruler and start taking some measurements off of that drawing. That is a massive no-no, part because drawings are always going to be printed with some aspect of scale in most cases, and just that's not the way we go about it. In terms of measuring the object, you take that from the dimensions, right? The dimensions are the ones that are actually printed on the drawing itself, and that's how you get all your dimensions to create your object. Never actually measure from a drawing. Now, keep in mind, particularly with some very simple drawings, you might not have any scale, and in that case, you'd put none down for scale, right, if you're something you're not worried about. But for nearly all of our drawings that we're going to have to do, scaling will become important once we have start using layouts and whatnot. Now let's get into the actual drawing commands. These are all in the draw panel, right? That's in your home ribbon. Right? And if you take a look, your draw panel is going to have these following commands. We're going to have line, right? That's just when you want to just straight line. Polyline. Polyline is just a series of lines that are connected together. They can be lines, they can be arcs. So we use the polyline command to create some more complex shape. We have circle, right? We have arc. We have polygon. Right? Polygon essentially is a closed object that's made up of multiple lines. The most common polygon you're probably going to use is the rectangle one, but there's other options there. Now we also have the rounded shape, our ellipse shape. We'll get into hatch. Hatch is when we want to fill something in with, say, cross hatching. And keep in mind, this is a flyout window. So there's a whole series of other commands down here on the flyout, including this construction line here, known as the X line command. That's something you're going to use a lot during the construction of your model, particularly when you have multiple views. And a whole series of other ones in here that are used less often, things like points and donuts and whatnot. We're not going to go exhaustively go through all these commands because you just don't use them for most of the drawings you need to do. So within each draw command, you're going to see there's a number of different options. So for example, if we look at the circle command, right, if you were to type in circle or hit the circle button, and then you look down at the command prompt, AutoCAD asks you to specify the center point for the circle. Right, so that's a common way of drawing a circle. You pick a center point, then set a radius or a diameter. But keep in mind there are other options, and you can tell that because they say or. One way to draw a circle is to just pick 3 points. That's the 3P option, and the circle will go through those 3 points. You can use 2 points, right? And the 2 points are essentially going to be on a diameter of the circle, and the circle will go through those 2 points. Or another option that can be very powerful at different times is tan radius. So it means tangent, tangent, and radius. So for example, if you want to fit a circle between 2 lines, you can say I want it to be tangent to one line, tangent to the second line, and have this radius, and AutoCAD will generate a circle that has all of those characteristics. Right? The textbook will go into more detail on these various options, but keep in mind they're always available here at the command prompt. Right? If you go into the rectangle command, it's going to ask you to specify the first corner. Right? And then again, there's that or, right? The question is, do you want it to have chamfers? Do you want it to have an elevations, a non-zero Z value? Do you want to have fillets? Do you want it to have a certain thickness or a certain width, right? So if you just pick a point, a first corner point, it's then going to go to the other corner point, right? And again, you can do the other corner point or the option of I want the rectangle to have this area, or the rectangle to have these dimensions, or I want it to rotate. Right? I don't want it lined up in the X and Y coordinates. I want it rotated at a certain angle. Those are options of the rectangle command. Now, you're oftentimes going to have to put text on your screen. So the question is, what do you want your text to look like? And it's similar to the kind of options that you have in, say, Microsoft Word. So for example, you can say, what's the font name? Do I want Arial? Do I want it some other style of text? What's the style I want? Do I want it underlined? Do I want it bold, etc.? Right? And then you can make it annotative. We'll talk about that. Annotative is this way of making sure that your text stays the right size, right? And in terms of your text, you can have it be upside down. Right? You can have it be backwards. You can have it be upside down and backwards. You can change the width factor. So for example, you see over here, this text has been stretched out. Or you can change the oblique angle, like if you wanted it an angular, right? Here's its upside down. Here's its backwards, right? So these are all different ways you can do your text. You probably ask yourself, why would you want something upside down or backwards? Well, let's say you're doing something like a decal that eventually is going to stick on something, right? That may be a reason for doing something backwards. Or it's going to be on, say, something you're doing on a window or something like that where you're going to be viewed from the other side. That may be another reason. All right, so they're probably not something you're going to use very often, but in a few situations you might find it really helpful. And this is all controlled by the style command that allows you to set the text, the font, the size, and all these other particular details. Now, once you have your text style defined and you want to start putting text in, the simple type of text command is to use the text option. If you just type T, that'll create a single line of text, right? First thing you got to do is pick a point, right? And then it's going to say essentially where do you want the text to be, and then it says, okay, what do you want your option to be? Do you want it to be aligned? Do you want it to fit into a box? Do you want it to be centered? Do you want it to be middle or justified to the right? And then, of course, there's all these other justifications: top left, top center, top right, middle left, middle center, middle right, bottom left, bottom center, bottom right, depending on how you want your text to fit inside the box that you've created for it. Now, if you want a more powerful text editing tool, you want to use multi-line text, or what's known as M-text. Those options are available from the home ribbon. If you take a look in the annotation panel, here's your text, right? By the way, you notice this little arrow down here. That's that flyout, so there's some options here in text. Or if you go to the annotate ribbon, if you switch ribbons and go to the text panel, multi-line text is there. It's just the option. So you can do it a few different ways. The easiest way is probably just type in M-text, but also finding these buttons works as well. So this will activate a text editor, somewhat similar to what you'd find in, say, Microsoft Word, in that you're going to be able to see what your text style is, going to be able to control the size of the text, you're going to be able to control the font. Like, say, for example, you want Arial or another choice, you can see all your different text font options if you fly out. Here's your justification. That's, for example, top left, middle left, bottom left, all that kind of things is the justification. So let's say you want bullets, you want to space your lines differently, you want to create things with multiple columns. It's a whole bunch of symbols here that you want to be able to insert, things like the diameter symbols, radius symbols, etc. Those are available here in the symbol command, right? It also has a built-in spell checker, which is particularly helpful in some cases. And then your text itself is going to be in a box with a ruler, right? So it has things, for example, as tabs and things like that. So you are able to create much more detailed text using this M-text editor that will pop up. Now, the assignments for Unit 2 is to get started reading Chapter 2. Right, this is going to be drawing in AutoCAD in your textbook. This only have to do the first part, so that's sections 2-1 to 2-17. So those are the ones that are only responsible for Unit 2. In Unit 3, we're going to finish this chapter up. The other thing is these drawing in AutoCAD videos. Remember, we talked about how you can access these AutoCAD videos, and recommend you go through the first 15 of these. Now, these are all about 1-2 minutes long, so they're not like really long videos, but as you read through the book, you'll get to different points and they'll show you those videos. Right? Very important that you go through and use it. What this covers, for example, is the user interface and coordinate system. It covers printing, it covers creating and modify commands, and it also has those chapter exercises in there. So those are all important, and they'll be in videos 1 through 15. Now, in terms of the assignments you have to hand in, these are going to be your tutorial drawings. Right? The 3 tutorial drawings you're going to need to hand in is the user coordinate system drawing using coordinates, and the wagon, right? The wagon tutorial, right? Keep in mind, for these, you do need AutoCAD, and going forward, you're going to need AutoCAD. So if you haven't been able to figure that out, definitely get that figured out. If you have to talk to me about it, definitely do that, but don't wait on it. Make sure you got AutoCAD up and running. This is going to be due on Friday of the second week of the class. In terms of the quiz, That's always going to be due on Sunday. That's going to be due on the Sunday of the second week of the class. In terms of exact dates, take a look at your syllabus or on the Learning Management System, LMS has all the due dates. In terms of what you're specifically responsible for, this is what it should look like. That should be what your user coordinate system looks like, right? It's essentially a box with a circle in it, but keep in mind the dimensions are very important. So it should look exactly like that. Then we have drawing using coordinates, right? And that's going to be this kind of U-shaped object here. But again, these angles should be exact. These distances should be exact. You need to use your coordinates to create this object. The last of the assignments is your wagon tutorial. This is what it looks like in the finished one. One of the questions people always ask is which should be the, what do you need to hand in? Well, you want to hand in whatever is the last image. So in this case, the tutorial, the last image of the tutorial is after they've modified the wagon, modified the stop sign. And again, it should look exactly like this. You're given the coordinates to draw this and the distances and whatnot. So it should look exactly like this. So hopefully this is pretty clear what you're responsible for. Those 3 drawings need to be handed in as PDFs.